Coding can sometimes cause wrist pain that doesn't seem to be fixed by resting, bracing, or other methods your doctors have recommended. And if you're watching this, you realize that exercises are important to fix your problem, but sometimes it makes the pain feel worse. And this might have made you give up on doing your wrist curls and squeezies, but most of the time it's because you don't know why it can actually be helpful, or how long you actually have to do them consistently to see results. Adaptations take time, and knowing what to do in situations of increased pain are even more important. This video is going to help you understand more about why exercise is important for your wrist pain as a coder, programmer, or developer. We'll be talking about what actually happens at the tendons that allow you to do more with less risk of pain or irritation, and why sometimes it will get irritated. And of course, we'll talk about some simple strategies you can adopt to make sure you can keep making progress. Tendons are the primary cause of problems at the wrist and hand resulting from overuse or repetitive strain. If you've been following our content, you know this because we are utilizing the same muscles and tendons for extended periods of time with our activity, typing, clicking, gaming, playing music, or more. And the tendon tissue eventually gets irritated as a result, leading to your pain and inability to use your wrist and hand. But what does irritated really mean? And how do exercises help prevent this from happening? Let's get into the science. Every time we press our keys or mouse with the muscles and tendons of our wrist and hand, we are pulling on these tendons with each repetition or contraction. Framework upgrades and code refactoring might lead to 10+ hours of mouse and keyboard use for multiple days in a row. Ouch. Tendons are ropes of collagen fibers that are bundled in nature. Think of it like a rope with a bunch of different fibers that make up the larger rope. And within each of these bundles, there's little tendon cells, which are sensitive to the pulling of the fibers. The tendon cells are these little round dots. And these images over here show what a healthy tendon looks like. The fibers are nicely aligned, they're not broken up, while these images show what the tendon looks like when it's irritated or there's too much stress. Water fills up the spaces, the fibers become more weak, they become more disorganized. Think of it again like a rope that has strong fibers intertwined nicely and are well packed. When the rope is pulled too much, sometimes it can fray, space opens up, and it can't handle the stress of pulling as well. This is exactly what happens to our tendons, and this is what has been shown based on the research looking into tendon pathology. So what does exercise do for us? Isn't it also considered stress or pulling? The right amount of exercise or load allows the rope to become stronger, and there are real changes in the tendon that occur as a result of this. And additionally, the muscle itself, when you do exercises, can begin to handle more stress. So it can lead to more even pulling on that tendon rather than uneven pulling if some fibers are fatigued. When we provide healthy load to the tendons, here's what actually happens. The casing and surrounding of the tendon better manages the fluid within to help better handle stress, but also glide alongside each other more effectively. There are cross-links that develop that also increase the amount of stress that can be tolerated. But even more unique is that the fibers themselves become stronger, and that's controlled by the type of collagen within that fiber. More of the stronger collagen type 1, makes up the fiber rather than the weaker ones, type 3 and type 4. So thinking again of that rope, a fluid and casing is wrapped around the rope to keep the fibers in optimal shape and allow them to slide well against each other. Then the rope has steel fibers instead of manila or cotton, that type 1 versus type 3, type 4. This makes for an insanely strong rope or tendon that can handle more stress. But guess what? It takes time. Tendons take much longer to adapt than muscles. We know nervous system adaptations can occur as quickly as 2 to 3 weeks, which means better signaling from the brain to the muscle, while the muscle tissue adaptations can take around 6 weeks. Tendon tissue at minimum takes around 8 weeks to fully remodel in this way. But again, it doesn't mean that you have to wait 8 weeks to see progress. It just means you have to be patient and you will see progress along the time. Most of the time we see progress in the 2 weeks because of the nervous system changes. We see even more around the 6-week mark as the tendon is beginning to change, but the muscle has improved endurance. And then things fully resolve when the tendons continue to adapt to higher endurance. This is of course the ideal scenario with no flare-ups. Life and recovery are obviously more complicated, and that is why it can sometimes extend recovery even further. On the flip side, there are cases in which tendons, because they aren't as irritated, can recover more quickly, and the muscle endurance plays the larger problem. But the bottom line is this: stay consistent and be patient as you navigate the ups and downs of the 2 months of adaptations. Everyone starts at a different level of conditioning, and so this will affect how long it will take for you to recover. But now that you know the science, you're probably wondering what the right exercises are for your problem. When we have pain at different regions of our wrist and hand, it's always associated with a specific muscle and tendon responsible for certain movements of our hands. When we lift our fingers up, it involves the extensors. Pressing the thumb button a lot to swap between keyboard layers, the thumb. A lot of movement of the mouse side to side, your ulnar and radial deviators. Pressing our keys or mouse, our finger flexors. And fortunately, you've stumbled upon this video and channel. We have free routines, exercises, and guides that can help you determine what exercise will work for what region of pain and which tendon is involved. You can check those out in the description below. And now it's about doing it, so get moving. Ooh, 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 ooh.